Okay. Hi everybody and welcome at CERIAS Security Seminar here at Purdue University. Today's speaker is William Eng, who's an assistant professor at NC State, and he's going to talk about how to defend users against smartphone apps, about some of the work that he has been doing in this area and also future directions. Will?
Thank you, Christina. And thank you, everyone, for coming. This is sort of late in the day, and I think next week is your fall break. At NC State, our fall break is this week, so everybody's sort of antsy for various travel plans and such coming up. So how many of you have done research in smartphone security? So have you been asked, or have you actually asked the question, what's different about smartphone security? So this is a question that I've gotten quite frequently over the last number of years, and I want to answer it in a slightly different way. I want to answer the question of why study smartphone security. And so I think that there's a number of answers to this question, and the first one that's up there is sort of the blunt one, sort of the truth for a number of researchers that I've talked to in sort of research papers is, hey, it's a hot topic. Let's look at this area and sort of explore and see what we can do here. People like to see new things on new platforms. Usually the thinly veiled sort of reason upon a lot of smartphone security research you see is, hey, it's a resource-constrained device, right? And up until maybe the mid to late 2000s, this was really the case. Smartphones are not very powerful, and a lot of work was looking at not only how do we deal with these sort of computation limitations, but also sort of the network limitations. But smartphones that we have now are much more powerful. This phone is more powerful than the computer I had in undergrad. I like to believe that wasn't that long ago. And so are they still resource constrained? Well, they are to some extent, and I think particularly in terms of energy consumption, right? If your phone doesn't last an entire day on one charge, you're going to get a new one. Right? And so this is a big concern for a lot of people. And so when we were making enhancements to smartphones and adding new security mechanisms, this is something that we want to be cognizant of and measure if we can. I'm guilty of not always measuring power consumption because it's tough. Right? You can't just look at sort of battery use because it doesn't decay linearly. Now the reason that I came and started working in smartphone security research a couple years ago is the third one. Right? There are different risks. And this is sort of gets more to the first question of what makes smartphone security different. It's about the threat model, right? When we look at a threat model, we look at the stakeholders. And there's some similar stakeholders we have for smartphones. We have the user, we have an application and service provider, and we have a network provider. But the risks for each of these stakeholders changes. AT&T cares more about what you do on your smartphone than Comcast cares about what you do on your PC at home. Right? The telecommunications network is more fragile. They have services that you're going to pay for, SMS and tethering, right? And they care more about what sort of attacks can happen from phones. And then from the user side, there's intensified risks. We have a phone. We carry it with us wherever we go. It's always on. It's always collecting information. And it's doing that just as a matter of operation, right? As you use the phone, the task of the many apps is to collect information, like the address book, or using a location-based search application. It's just collecting lots of information, and we have that on our phone, and we're taking it between lots of different wireless networks that we don't necessarily trust. We're running lots of apps from who knows where, getting access to these resources. And so we need to look at those sort of intensifies risks and how that changes the scenario. The fourth reason that I came up with is one that I much more recently came up with is sort of that I believe pretty strongly that smartphones are really the direction that computing is moving. So consider the internet and what the internet has done to technology, right? So the internet is about having access to information wherever we go. It's about access to lots of decentralized services and the commoditization of those services. And that, in effect, is really what smartphones provide, right? You always have your smartphone with you. You're always getting information. You commoditize those services. You commoditize the internet. This is what apps are. We're paying for apps. And so in a way, then you might say that maybe smartphones are about apps, right? If I were to define a smartphone to you, I would say a smartphone is a cell phone that allows a user to download and install third-party applications from the internet. Two operative parts of that is the user chooses the software, and that software comes from unknown developers that are more or less untrusted. And so smartphones are really about apps, right? This idea that even the term app wasn't really introduced until we had sort of the iOS and iPhone that came out and everybody started talking about apps. So what's an app? An app is software, right? You download an app to your phone and it runs software. But if you look at a lot of those apps, they are really just access to web pages, right? Just these web views that access a web page. So I did a little preliminary survey, look at different applications that were in the Android market, and I came with some classifications. So sometimes apps are this sort of interface to a service, and like Facebook or Google Maps, right? It's this sort of interface to some web service that's out there. Sometimes apps are bringing content to the user, like an ebook or streaming video. And sometimes apps just have some specific utility that you might have had on a PDA, or maybe a little enhanced with the sensors that are on a phone, like a compass, or just an app that's going to give you recipes for cocktails, something useful. And so my takeaway from this little survey was that an app, the word app is really just a conceptualization of computing. It doesn't matter where that computing is happening, whether it's happening in the cloud, happening on the phone, or somewhere in between. It's computing that is happening for the user. The end user doesn't care about these things. And so this is the model that we're really shifting into in terms of computing in general. Now, the way that we deliver apps to users are application markets. This is the App Store, Apple's App Store, or Google's Google Play Store, which used to be called the Android market. And there's lots of these application markets. Each smartphone vendor has one. We're starting to get them now for PCs, right? The App Store on Mac is now available for OS X. Windows 8 is going to have its App Store. And this is sort of a revelation that came about with smartphones. And it's pretty important in terms of how these devices have evolved. Because there's lots of benefits to having these application markets, and even non-security benefits. If you think about what they provide, to the user, you allow the user to very easily discover, purchase, download, install an application with a few clicks. There's no lengthy process of going to download.com or 2cows and finding an exe that works for you and then going through some lengthy installation process. Right? It happens very quickly and very easily. From the developer side, the developer can post their app and allows the application market to do a lot of the advertising, the sales, the distribution of that app, and there's a lot of benefit from the developer side. And this allows developers to very quickly create new software and publish that software out to have lots of people use it. And so the whole ecosystem that we're seeing now on applications and on smartphones in terms of their applications is really brought about by these application markets. But that's just an overview of sort of where the area is in terms of technology. My goal today is to look a bit more into the academic research that's been happening in the space with respect to security. This talk is a variant of a keynote that I gave at a conference last December, and that gave me the opportunity to write a survey paper of looking at all this research, which I then incorporated as the outline for a special topics class I taught last spring. And I want to impart some of that to you guys. And so what we're going to do is we're going to look at some broad approaches, some things that I've done, some things that other researchers have done, and see how do they work. First, what are those approaches? What are the limitations of that approaches, and sort of how are things moving? What works, what doesn't work, and at the end we're going to conclude with some additional directions. Some of these directions have some papers that since sort of I wrote the initial survey have been some work in the space, and I think there's definitely some more work to extend off of those. So I think we can have this a little interactive. If people have questions as we go along, please raise your hand, call out, make funny noises, and we can sort of have a discussion about these things as well. So when we talk about smartphones, there are a number of major platforms. The ones you hear about the most are Android and iOS. Windows Phone is still in there. Windows is going to pump as much money into the smartphone platform until they are back as a player. This is because this is where a lot of computing is happening. BlackBerry and Symbian are sort of trailing off. BlackBerry is right now sort of a little bit more behind than Windows Phone is. They're going to have their BlackBerry OS 10 coming out, I guess sometime next year, but a lot of people are speculating that BlackBerry is going to have some big problems sort of keeping up with Android and iOS. And so maybe BlackBerry should also have a question mark up there. But Symbian is the first real smartphone platform that existed. And it didn't exist a whole lot in the United States. It just didn't kind of come over the borders into carriers. But when you look at Asia and you look at Europe, and this is where Symbian has really sort of thrived. But even Symbian now is starting to be replaced with some of these other operating systems. But when it comes to research, really most of the research has been on Android. There's been a little bit on iOS, but most of it's been on Android. And there's, I think, two primary reasons for that. One, it's much more open. Right? It allows developers or sort of researchers to get their hands dirty, figure out what's actually happening, test that their ideas work by modifying the Android operating system. It provides much more transparency in terms of the applications. We can find permissions on applications really easily to look at the interesting stuff quickly. So that's a large contributor. The other is, and the reason why I started looking at Android initially, was you can do things in Android that you can't in the others. Android is a very flexible and modular architecture that allows you to have a mashup of applications working with one another. This is great from functionality point of view, and it's really had Android sort of thrive over the past number of years and sort of catch up to iOS. But it also opens up a number of security problems, which for security researchers like us allows us to look at new and interesting problems and come up with new solutions. So a lot about what I'm going to talk about today is really going to be focused on Android, and this is primarily because this is where the research has been. Now, looking at sort of how smartphones are structured, for those of you who aren't familiar, two main parts. You have the delivery of applications from an application market to a phone, and then on the phone, you have an architecture that's very much like what you see here on the slide. You start out in the hardware, right? And so you have an application processor running the application OS, and there's a baseband processor running your radio, and those are really isolated from one another, and some TTY, sort of serial connections between them. On top of that, you have a standard OS kernel, right? iOS has Darwin, Android has Linux, and so this sort of is the foundation of the sort of the fundamental OS support primitives, the system calls that are actually happening. On top of that, you'll have some middleware layer of APIs. Android has its sort of component abstraction. iOS has its own sort of middleware based a lot on what's in OS X and the sort of the Cocoa framework. And then on top of that, we have applications running. And these applications, as we'll talk about in a little bit, are very isolated and are running sort of beside each other, working with one another. Security research has looked at two areas. One, how do we enhance the protection system, or what are the problems in the protection system on the host side? And the other is, how do we analyze these applications that are coming down? Can we find security and privacy problems in these applications before they ever hit the phone? They're coming from this application market. Can we leverage that? So from the point of view of a smartphone, fundamentally the OS architecture, the security architecture is different than a PC OS security architecture. We don't worry about different users. We assume one physical user of this device, and so now we move our security policy from being about users to being about applications. And so each application we're going to run sandboxed, and then we're going to give it access to the different security sensitive resources on the phone, like your address book, your GPS coordinates from that GPS hardware, the camera, the microphone, and we're going to assign these with permissions. Those of you familiar with more traditional security terminology, these are just capabilities, right? Capabilities to access these resources. So security on smartphones are about permissions, and we're going to use these permissions either at runtime or install time to make security decisions. These permissions can provide a number of things. On Android, permissions are most well known by having these sort of install time permissions, like you see on the slide here, where an application will request these at install time. Researchers we'll talk about later have looked at this as sort of confusing for some users, but there are some good things. For expert users, you have an idea of what might happen. You provide some defense in depth if applications are exploited. And then when you're actually doing research on these apps, permissions are great because they allow you to focus on the apps that have the properties that you're interested in. Because if you don't have one of these permissions, if you don't have the permission to access the microphone, well, this app isn't going to be able to read audio from the microphone. And so this is a nice sort of foundation we can work from. When it comes to security research, there's been a number of works that have extended on this sort of permission model. Permissions are really just a rule set of security policies, sort of a very primitive form of security policy, but it's security policy is sort of an articulation of rules. And so over the years, various smartphone security research has enhanced this in different ways. And when you look at these rules, you say, okay, what are the rules trying to provide you? And so the initial work, starting back with some extensions to J2ME with these very early smartphones, and security by contract, which was developed for Windows Mobile, this is pre-Windows Phone. And their security policies were describing resource utilization, right? Can I put a cap on the number of SMS messages you send in a period of time, or a cap on the data resource used by a specific application? Those are the sort of security policies that were initially being looked at. Following that, some of my work, the Kieran project, was looking at these install time permissions that we have, and can we do some constraints on that? Right? Can we look at combinations of these permissions and say, hey, this might be dangerous. We want to prevent this from ever happening or being installed on a phone. This again is just sort of a list of rules that we have. Beyond that, systems like Saint and Xmandroid look at interactions between applications. Right? So these policies form much on the level of what developers want to look at. Right? So I have some information that my app has. How do I define a security policy that is going to prevent some other application from accessing that? So Android's permission model for security policies might not be expressive enough for that. So we're going to add some more features in there. And then there's a number of works that have tried to add some more fine-grained permissions, or looking at sort of your context. So I can only access the camera when I'm in a specific location, or maybe not access the camera when I'm in some secure facility in that location, or with time of day, or these sorts of things. And so these are sort of a broad spectrum of different types of security policies that have been rule-driven that some research has proposed for smartphones. At the bottom here you see, this is actually from Kieran. Here's just an example. Here's a list, right? It's just a list of very specific requirements that you have to sort of work at individually. And so when we look at these rule-driven policies, and this is more applicable just for computer security in general, is you have to look at the policies that are being created, and how do you create them? And how do you determine what should these policies actually say? A lot of these policy systems that have been created are essentially creating new policy languages for the sake of creating policy languages. This is something researchers like to do. Look at this great expressiveness we have for our security policy. But who's actually going to use that? Right? And so when you're doing research and you're looking at the new frameworks that you want to build around these existing security frameworks, try to figure out, well, what's the motivation for that? And I want to go to my Kieran work as sort of an example. The first iteration of our Kieran work had a very expressive security policy mechanism. We used some first-order logic that we could look at lots of different permissions that applications had, installed applications had, and you could write logic queries on those permissions. And it was tough to motivate. Tough to motivate a lot of our expressiveness of our security policy. So we took a step back after getting the paper rejected more than once. And when we took a step back and said, what is fundamentally going on here? What do we actually want? And we turned to security requirements engineering. And so this is an entire field of security research that looks on how do you actually come up with the security requirements, which are essentially these rule sets. And so we did this to an Android phone, and we used that to come up with this list that I had on this previous slide here. Right? We used that methodological tool, and it wasn't completely automated. We couldn't just run some automated tools with that, but it was structured. It was sort of methodological in determining that. And it's something I encourage to sort of look at when you're defining new security mechanisms, particularly when they're rule driven. Look at what do you need, right? And so I remember the response and the reviews for the Kieran paper. One of the reviewers said, "It's simple, but it works. I like it." Right? And so sometimes when you have a system that's easy to get your head around, there's a lot of value to it. Now, with Kieran or any sort of rule-driven system, one thing to watch out for is how do you maintain those rules? Who defines those rules? And is this going to be the user? Users are not always capable of defining those security policies, particularly when we go back to those per resource consumption. Right now that we have 2 gigabyte or 4 gigabyte caps on our smartphone usage consumption from Verizon and AT&T, right? It'd be great to say, this app can use this much data and this can use this much data, but someone's got to go and define that. And that's a sort of a process that you need to get around. Now, we've also learned from permissions, again, permissions being a type of rule-driven policy, right? They're tough. Just these simple permissions, these list of security policies that the user is going to confirm, right? So if you look at some of Adrian Felt's work, sort of confirming a lot of our intuitions, she did some user studies that were surveying users' comprehensions of permissions. And by and large, the users they talked to didn't understand them. They didn't understand what the permissions were conveying and what they were trying to prevent. And so even with permissions which were very simple, users were having trouble. So if you're going to define a much more complex rule-driven security policy system, keep in mind somebody has to administer that. And then the last part is, how do you know when it's right? This is the biggest challenge with a rule-driven security policy, whether it's smartphones or computer security, is it's just a long list of individual requirements. And there's no correctness check that you can put on that. So again, this is the problem that's existed in computer security for over a decade, and so the approach that computer security research has done is look to sort of more high-level security goals. If those of you familiar with the space, you think about the classic mandatory access control systems like Bella, Padula, and BIBA, where you have a sort of a mathematical model that's going to enforce the security guarantees you want, and then you push that model onto your system, and you try to use that then to demonstrate that we have these higher level security goals we want. And then you can say, is it correct? Yes, because we were able to show that this higher level goal is correct. And we've seen this emerge in different ways in smartphone security research. Some of the first work I found doing this is by Colin Molnar, some of his co-authors, and this was, I think this was a Windows Mobile smartphone paper back in 2006, where they wanted to prevent what they called cross-service attacks. And so if you had a requirement that says an application cannot talk to both Bluetooth, or sort of use both Bluetooth and the cellular network, for example, this would prevent a Bluetooth propagated worm from attacking the cellular network. And so they were able to sort of apply this sort of higher level goal and enforce it within their framework. Now, more broadly, in terms of domain isolation, this is, think virtualization, right? So you have applications running with different security requirements, like business and personal apps. You want to have them separate, right? This is a high-level goal that you want to use, and so VMware has a nice little solution out to virtualize your business and personal OSs. At SOSP last year was the Cells paper, which again sort of adding some virtualization in a lightweight way into an Android phone. But you can also push it down a layer, right? It doesn't just have to be strictly from the OS. And there's the L4 Android project, which takes the L4 microkernel, makes it what they call a microvisor, right? So basically, it's a microkernel used as a hypervisor. But then they run run 2 instances of Android under that. And if you're familiar with how sort of L4 works, is you have a Unix process, right, that provides all the services to the rest of the framework. And so they've taken Android and they've run it as this Unix process, and then you have a lighter weight way to do this separation. But you can still push this down further still. And so there's work Trustroid at a small little workshop last year that said, well, within the Android operating system, let's start coloring applications, and then we want to prevent interactions between different colors. And this was useful because it allowed you to say, this application is personal, this one's business, but we're going to allow this to work with a trusted system service like the address book, where we can have one address book on the phone or one calendar on the phone. This makes the system a little more usable. And so another area we've seen sort of this high-level policies is the IPC inspection work out of Berkeley. And what they did here was they tried to prevent a variant of a confused deputy problem. And this is where there is a sort of privileged system process or a privileged application that has permission to access some resource on the phone. And it is now going to re-export that ability to some other application. Right? And so because of the way that Android works, and you sort of very modular, one application can call another application, and that can call another application, right? The one in the middle might be re-exposing that service. And the one on the end that actually had the resource might want to know, well, who originated that? Right? Did the application that originated that call actually have permission to do that? And so they went and took permissions as sort of a way of sort of reducing the privilege on an application. So you'd have to have, if you wanted to access the camera to read a barcode, but you use the barcode application in the middle, your initial application would have access to the camera, it would access your barcode application, and then that would access the camera. And so as we've moved down, we actually would reduce the sets of permissions given to this middle application, but since we had access to the camera, we can still access that. If our initial application didn't have access to the camera, when that application accessed the barcode scanner, we reduced the set of permissions on that barcode scanner to not have the permission, and then when we try to access the camera, it doesn't work. And so this is really a form of BIBA low watermark integrity, if you're familiar with that terminology of security policy. And so this has really emerged within this system, which was recently proposed for the Android platform. Now, reflecting on that, there's some observations. One is this last little thing. While I found the IPC inspection system really sort of interesting from an intellectual point of view, there was a danger of something that they did. Is they took these permissions, which were originally created to be sort of non-transitive, sort of one-time access between different applications, and they added transitive semantics to them. They tried to make them part of this sort of higher level, higher order security policy. And this causes some weird ramifications in terms of the usability, right? And so what happens is, I said if that original application trying to use the barcode scanner to access the camera didn't have the camera in the first place, now the barcode scanner stops working, right? So in order to get around that, you have to create rules in order to allow that additional operation to occur. Now you're getting back to that rule-driven policy, and we're kind of back where we started. And so be careful of merging existing sort of rule-driven policies and pushing them into these higher-level systems. The other observation is with respect to the domain isolation work. Right? I mentioned as we move down the sort of the levels of granularity from sort of OS virtualization down to putting it into the operating system, we're getting some functionality back, right? If we just strictly isolate everything, it's much easier to secure, right? We know from a high level, hey, these are running on the same device, but they're running different operating systems, so we can maybe make some protections between them. But we lose things like I mentioned, having one address book, having one address that contacts one address book, sort of our calendar. All of these things we start having some problems with. So maybe OS virtualization might not be the end solution. What do we actually have ways of resolving that tension and pushing things into the operating system like Trustroid did? So these were two areas where there's been a lot of research. It really drives from a lot of techniques that have been used for for looking at operating system security historically in computers in general. It's been really moved and applied to the specific problems that we've seen in smartphones. Moving on, we've seen some work in platform hardening, and I'm going to move through some of these a little more quickly. So SE Android was announced, I guess, earlier this year, or late last year, earlier this year. And the goal of SE Android is really let's harden this underlying part of Android. Android is very structured when in terms of what process can access what file within the underlying system. And so there's some nice things that we can do there and sort of enhance the underlying part. We've also seen some work that's done some integrity measurement, right? Can we do remote attestation of phones? Can we do remote attestation of specific applications? Right? We're seeing some of the same things appear on smartphones. Now, this is good. We need to have this sort of research. We need to have this sort of capabilities. But it is a necessary but not sufficient condition for security on phones. A lot of the problems we find now are up at this middleware layer, where these applications are working with one another. And this is where sort of the previous two sets of areas where I talked about is really trying to drive. And the next area is really attention that's resultant because one of our underlying assumptions of smartphone security was wrong. Turns out, sometimes I give my phone to someone else to use. I have a lot of friends who, they're at a social gathering in a bar. They have some pictures on Facebook they want to show a friend, so they just hand them their phone. Or, hey, can I borrow your phone so I can check this web page for something, right? And so you lose control of your phone. And so there have been a number of user studies motivating having guest modes or different sort of profiles for your phone. And then there's been some research such as XShare and Diffuser that have proposed different models of doing that. And even Android, there's actually some remnants in Android 4.1 that looks like Android's going to try to move some of these things in there. Now, from a research perspective, making the functionality of multiple profiles is straightforward. Figuring out how to use them is a little harder, right? I have to remember to change the mode of my phone before I give it to you, right? If I don't do that, it doesn't matter how many different profiles I have on there. You're in my main profile. So maybe we can figure out ways that we can learn based on the user's behavior that we're actually a different user, right? And that might be a better approach than just requiring the user to do that input. Another area there's been a lot of research is fake information, right? So what has happened in terms of the studying of applications, which I'll talk to you about in sort of the second part of this, is that there are a number of applications that are leaking private values. This private information is not necessarily required for the functionality of the application itself. It's maybe used in an advertisement or sending some analytics back to the developer. And so to combat that, some research says, hey, let's create fake values, right? I don't have to give you my phone number. I can give you a 555 number like you see in Hollywood. Or location, I can give you the coordinates for the North Pole, right? If the application doesn't need that. And so there's been a number of ways of proposing to do that. One of the more interesting of these is the last one, AppFence. And they did sort of a two-tiered structure. They said some data we were able to find that you can just give it fake information. Other data, we had to give you the actual information, but we were able to keep it on the phone. And so we were doing some information tracking based on the tainted system, which I'll talk to you about a little bit for analysis. But they used that to keep the data on the phone. And what was interesting about this was that first class, it really isn't needed for the function of the phone. Why are we actually having these APIs if we're able to, in general, provide that as fake information? So this is sort of an observation, I think, out of this research has come this sort of larger idea that there is a tension that developers are using parts of the phone, parts of APIs that the users may or may not want to be involved. Switching gears a little bit, throwing a lot of sort of areas at this, but there's been a lot of interesting research in this area. We moved to the sort of the application side, so the analysis side. And as I mentioned before, the primary way of getting apps to phones is through an application market. Now, application markets can provide some nice security properties to phones. We can, if we restrict an app like an iPhone to only using things from one app store, well, then we have this sort of walled garden model. Now, this isn't restricted to just iPhone. On Android, if you don't check that allow apps from unknown sources, you have essentially this sort of walled garden model. And so this provides us a nice choke point to be looking at apps as they're being installed on phones. They also provide this very nice reactive measure, which has come to be known as kill switches. Right? I can remotely uninstall an app from your phone if I later decide that it was malicious. Now, there are some negatives and positives from this. If you remember a few years ago, Amazon was caught removing copies of 1984 from Kindle devices for copyright reasons. Well, the same sort of thing could happen here. And so there are sort of negative implications. But I think in sort of the net gain, there's a net gain in terms of being able to do what's essentially, antivirus cleanup on phones without forcing antivirus software to be on all of these devices. And it's really a form of remote management that users, they don't care as much about, right? A user's going to care if you have a administrative login in your system and we're going to be controlling your apps. But if we provide this feature where it's really rarely exercised and it's always beneficial, well, users are more inclined to be accepting of that. However, you can't do everything at the market level, right? App markets can't provide a complete security solution because there's some things that we want to check at that level that differ, right? Some users care more about privacy than other users, and you can't cater to all users at the same time. And so this is one difficulty. Another difficulty is it's really hard to describe what we want to check, right? What does it mean for an application to not have any security problems? Even if we're just looking for malicious stuff, how do we define what malicious is? And so there was a broad area announcement, sort of a call from DARPA for research proposals last year that gave this great example. And they said, we want to start out with this idea that we want to have this application contains no malicious code. But that's a really hard question to answer. Right? You can't build security tools to answer that question. So let's refine this. So one way we can refine this is look at specific topics like this push-to-talk application is not an eavesdropper. It's more of sort of the security goal that you want, but it's still very hard to analyze from a sort of a static analysis certification point of view. So we need to take it a step further. This push-to-talk application records audio only when the talk button is pressed. Now that's something more specific that you can verify with program analysis. And so that's the level which you have to start breaking down this definition of this application contains no malicious code. Now, if you remember the discussion we had back with rule-based policies, it's sort of the same problem. How do you know when this definition of no malicious code is actually complete? You don't. Right? You make this list as exhaustive as you can, and you check for those things. So there's always going to be things that you might not have checked for or checked for in the way that you've actually defined them. And so there's always going to be things that are going to slip through any application market, no matter how much security analysis it performs. Now, when it comes to the research, researchers have looked at different types of analysis of applications. They started with permissions. The CERIAS system I mentioned to you from sort of the enforcement, the policy point of view, was really a way of doing some lightweight certification of apps based on those permission combinations. But researchers have also did much broader studies looking at what are the properties, what are applications actually doing. Two studies in particular, so David Barrera at Carleton and Adrian Feld at Berkeley did over the last number of years, and they looked at large sets of applications, and you sort of get a takeaway from their papers, whether or not they say these things specifically or not. Some of these they do. Apps really don't request lots of permissions. There's this big fear when Android came out that every app was going to request every permission and the permissions were going to be utterly useless. There's actually a relatively few number of permissions that most apps request. So that's good. Categories don't predict permissions. The study by David Barrera and the Carleton folk was really using some machine learning techniques, and they tried to correlate categories, so the category in the market to the permissions, and there really wasn't a good sort of relation between them. So that's not really a good predictor when you're building systems based on that. So developers don't always know the right permission. Developers are using permissions that don't even exist. A lot of them are copying code from Stack Overflow or different sort of how-to websites. And so you can't really always rely on the developer of knowing what they're doing when they request permissions. And the last one is sort of, there's been a lot of press on this, Android permissions are pretty coarse-grained. This is a known problem, but how do you get more fine-grained without really impacting the user for what they have to do? Overall, though, permissions, not only the coarse grain for the user, but they're also coarse grains in terms of analysis. Right? The problem we had with the Kieran work was there was still some variability. Right? One application was a GPS tracker. It had the ability to track your location, get your location, send to the internet, start on boot. But so did the weather bug application, which wasn't really tracking your location. It was providing you different functionality. And so we wanted to look more deeply into that. And so I created a tool called Taintdroid that allows you to do dynamic analysis, sort of what's called dynamic taint tracking of this private information like your location, your phone identifiers, the microphone, and figure out where that goes automatically as the app is using it. And then when you send it to the network, you can detect that. And so there's been some work sort of follow on using these techniques to sort of certify applications and some other great work sort of allowing you to sort of run these applications. But the biggest problem with dynamic analysis of Android apps is you get stuck. If you just try to fuzz or sort of provide sort of random inputs to these applications, you get stuck within the menus, or that application requires you to give a username and password, and you can't exercise all the functionality of these applications. Fortunately, recently, and this is much more recently, there's been some work that's trying to use techniques like concolic execution to make sure that we get to the different parts of an application, so that when we're doing this dynamic analysis and we're using these tools that have been created, we can automate it and actually get over those hurdles. Related to sort of the dynamic analysis, sort of more of a real-time analysis, there's been a number of proposals of why don't we monitor what's happening from the network point of view, what's happening on the phone. And there's some advantages to this, right? So you can look broadly at applications that are out there and look at their activities and figure out, is someone acting different than the rest? Is this actually malware that's starting to occur? Now, there's a lot of great things you can do with that, but you do need to be concerned that now we're sending all this private information, that the user activity, into the cloud. And so depending on the user's threat model, what they care about privacy, this may be a problem. Are they going to make the trade-off, the privacy trade-off, to get this greater security? And then the last area where there's been an increasing amount of work recently. So recently there's been a lot of work in static analysis of apps. This is one area where there's been some work on iOS. The PIOS work out of UCSB has looked at information leaks in iPhone applications, and they were able to work on binary iOS applications and find the data flow of location and phone identifiers. And they were seeing just the same sort of leaks of location and phone identifiers that we found with the Taintdroid work that was eventually used to motivate the fake value input. So this isn't just an Android problem. This work shows that it's also happening on iPhone. Some other works have looked at sort of working right on the DEX code. And some of my previous work on the DEAD tool, actually, can we decompile Android applications to get the source code, and we can work on them. But a lot of this work is really getting to the point, building the tools. And these tools are starting to become available. Some are public, some aren't public. But as these tools become public and more researchers gain access to them, we can start asking the interesting questions. What do you look for? And what's actually happening, right? And so how do we use these tools that are being created for different things? And so some of these tools, like the ad risk work, was looking at specifically at advertisements, sort of the information being used by advertisements from a static analysis point of view, and we're finding pretty pervasive privacy problems that were just in the advertisement code itself. And they were to use that because they could pinpoint it down with the static analysis tools. So those are really the broad strokes, and I imagine they're going to continue. We've seen them continue, but I think that there's some additional areas where there's definitely some need for work, and some of these I came up with a while ago when I made this talk, and there's actually been work in this area. The first one is let's not just try to prevent users from downloading the bad applications. Let's point them to the good applications, right? If we can help them discover the more security-friendly applications, more privacy-friendly applications, we prevent the problem of them going and getting those malicious ones in the first case. There's actually quite a few really low-quality apps out there, and those are the ones that have all these bad properties. So let's point them to the good ones. I mean, we can use consumer reports for quality, we can use consumer reports for security, and direct them towards those right applications. I have a paper at MOST, which is a little mobile phone security workshop that's associated with Oakland, where we have a tool called Meteor, which is a framework of how you actually might go about starting this environment. Modularity and transitivity. Android's very modular. Why should advertisements run in the same code as the main application itself? So researchers have looked at that. Within the last year, there's AdDroid and AdSplit are two different approaches to separating advertisement functionality into other applications. This is great because it provides us a lot of transparency of what part of the code is doing what. It allows researchers to focus on the right part. It allows users to be aware of sort of what parts of code are requiring what permissions. And so we're going to use these modularity to create further systems. Where else does this apply? Is this just ads and analytics? Or can we apply this to other parts of application functionality? Right? Android apps are really mashups in themselves. Can we get additional security benefits? Using the user's train of thought and what they're doing to enhance security. Great example of this in Android is making a phone call from an app. One way you can call the call intent requires the call phone permission, and the phone starts dialing immediately. Or you can use the dial intent, which opens up the phone dialer, inserts the number, and waits for the user to press call. Second one doesn't need a permission. The user's not really asked a security question. It's part of what the user's doing. Can we leverage the way that users are interacting with devices in a natural way to answer these security questions so we don't have to go back and make a bunch of rule-driven policies? And so recently, so at Oakland, there was some work, not necessarily on phones, but something called access control gadgets. And this tool was using known symbols like for a microphone that was in a trusted area of the screen. When the user pressed that, the OS said, okay, now we can record audio. Right? No permission was even required for that. And I think that can provide lots of benefits. And then the last area is how do we help the developers? The developers don't necessarily understand the security and privacy requirements for mobile phones, right? A lot of them are using these IMEI values, which the sort of general consensus of security researchers is don't use them. There's privacy problems. But developers don't understand that. So how do we create tools that help them prevent these actions from happening? Right? How do we enhance the environment that the applications are being built? When we do that, the general quality of applications will grow. And so I think there's a lot of room for development in that area. So with that, I'd like to thank you. I think there's a few minutes left for questions. Sorry I didn't give you a little more than that. But thanks. Yes.
So the biggest difference I see from the smartphone stuff and your traditional PCs is the markets. And what that will do is when if you have a PC, you'll generally have maybe these 10 major applications on there that are from very trusted places. You don't go download something that, say, I wrote, the general user won't. But now that you have these centralized markets, people might download something I write. But I write's not going to be as good as this big multi-million-dollar corporation, or it's definitely can't be as trustworthy. But now these traditional operating systems like the Windows 8, they're moving towards having markets. So is there going to be much different after that? I mean,
I think, like I said, so really what we're seeing in smartphones is the way that computing is moving, right? And so it's not necessarily it's different, but this is what we're going to be seeing. This is why we study smartphones now, so we can fix these problems as they emerge. And yeah, so these apps, right? The developers who wrote all these terrible PHP scripts back in the early 2000s are writing apps. They're writing apps for phones, and they're going to be writing apps for Windows 8. And so that's why when we talk about developer tools, right? How do we prevent a lot of those security bugs from existing, right? Apps are using your IMEI as the password. to log into services, right? These are really stupid things to do when we look at it as security researchers, but developers don't necessarily pick up all of those things. And it's not just these big development houses, it's not just Microsoft and Google making these apps, right? So New York Times needs an app, Fox News needs an app, and so they're not going to develop themselves. They actually contract that out to other developers, and so this is some of the work that I've done as well. This propagates problems as well, or these sort of different techniques for privacy problems, not necessarily in those applications, but those get propagated. And so, who's writing these apps is really underlying that question. Yep.
How do you contrast between the approach that Android is taking versus what Firefox is pushing, for instance? So they're pushing more towards HTML5 based web technologies onto the phone. So one thing there is, if you start improving the permission models inside the web itself, then they're universally applicable because people are moving towards the web.
So the computing has really been moving towards web browsers for a long time. And in many ways, what you see on smartphones are really web browsers. Right? A lot of these apps are very, very thin. And this comes down to a developer choice. And I think this is an area where there's definitely work to be done in looking at what's happening in this area. I don't necessarily think from a security point of view, but from a usability and performance point of view, when you work with an application that entirely requires you to refresh a web page, right, how often do you not have network access? It happens occasionally, and then users sort of are impacted by that. So there's trade-offs. I think Mark Zuckerberg recently said, we made a mistake using HTML5, we're going to native apps, right? Because it impacts the user experience. He didn't care about security in that point of view. It's more of a question of sort of experience. Permissions, you can do the same. They're containers, you give them permissions, you use code running inside that container, and fundamentally they're the same. Yeah.
So you mentioned about the guest profile and not requiring enter some information, instead detect the user behavior and guess who it is. I in first thought I feel like it might be more difficult because the UI is limited. So for example, typing behavior might be significantly different in normal computers, but it might not be that different in smartphones.
Yeah.
And so is there anything a little better or more challenging? Or?
So more challenging in terms of so there was there's a paper, not directly on this, but at Using Security this past year, progressive authentication by some people at Microsoft Research, and they were really trying to find continuity with your device. Did you sort of leave your device somewhere, and do I need to authenticate you again to improve just the general authentication? But if you start using those sensors that they're using for that, you might be able to use that to start identifying the user. And I think there, if you look around, there's been some literature trying to do exactly that. But we're not seeing it in phones yet. So is it practical? How do you actually make that practical? I think it's a big question. Yep.
I don't work in the security area.
Push the button.
Sorry. So I was wondering if are you aware of any work? I don't know if that maybe what you meant by the cloud monitoring. Any work that's based on crowdsourcing. So basically, say I can compare all the network traffic by the same app running on 1,000 different phones to learn whether this app is doing something strange, for example.
Yeah. So there was, I've seen some sort of workshop papers looking in this area, where, for example, they took the system calls from an application, sent it up in the network, and then used crowdsourcing based on that. Do these system calls map for this particular application? That particular paper, remember some of the but yeah.
The thing about the app is setting the privacy, right?
Yeah.
Private data, right?
Yeah.
So you imagine that's exactly the difference in terms of what's in the data. Exactly the difference between data going out of my phone versus data going out of your phone, because there's difference between my privacy information and your privacy information.
Right.
It's just intuition.
So what was your question?
Seems like a sensible approach is to just to go to crowdsourcing based approach. Basically, if you can collect such information of same app run in different phones, compare them, learn a lot.
Essentially, yeah. And so I can't think of it off the top of my head that's looking at just the network traffic, but I imagine some of the telecommunication providers are looking into this a little bit of they may look into it to some extent. I remember someone from AT&T talking about a system where they could sort of monitor different applications, but I don't think that they're looking at per application because they need to know this is this application that's causing this network traffic. But they definitely would look for anomalies in different ways. But so you get that context that might in the back.
Why is there no interest in pushing the usage of phone towards a traditional multi-user model? As in, you see that most of the times phones have either the root or the other user on which your applications and your phone and all runs. There is no segregation, as you said. If you give it to someone, there is no option of a guest mode. I mean, just adding one more user to prevent.
This is coming.
I'm sorry?
This is coming. I mentioned in Android 4.1 they added some primitives behind the scenes. So some people in XDA were exploring what do they actually provide. And that's the screenshot I showed you was from one of those developers sort of playing around with it, and it looks like Google's going to try to do that in future releases. Nobody knows for sure when that's going to come, but you could imagine something. How if you have an Android phone, you hold down the power button, allows you to turn it off or change it to airplane mode, or that switch profiles could happen as well, and then authenticate you. So it's just that's a matter of time, implementation. But there's this underlying problem of I still have to make sure I change the profile before I give it to you. So it'll handle problems when you give it to your kid. Say, here's my reduced phone. The kid's not going to send emails, but it's not going to handle all the cases.
Amount of importance, across all manufacturers, or is it just something that Android has kicked off?
I think so. So some of the previous research was built on Windows Mobile, looking at this. The user study was at Kai, was more of a sort of survey. Wasn't really an Android specific thing. Mm-hmm. So it just happened to be that I saw people were playing around with what's happening in Android, and someone saw it's there. I would imagine we're going to see it more broadly. Because I think it's something that people really want. But again, how do we figure, if we can do this automatically, even better.
Okay.
So.
Maybe that we can stop there.
Great.